There's a myth in the AI world that vector search is the silver bullet to ground your AI agents in your private company knowledge. But the reality is quite different. If you're building AI agents that rely solely on semantic search, you're leaving massive gaps in your retrieval. Gaps that can lead to hallucinations, incomplete answers, and unreliable results. That's not to say vector search is bad, it's brilliant for conceptual semantic style queries. But there's an entire subset of other queries that require different retrieval strategies to output the right answer. And in essence, this is retrieval engineering, designing your retrieval strategies based on the specialized scope and capabilities of your system. We've worked with hundreds of community members who are building production-grade RAG agents, and we are seeing the same patterns over and over again. So in this video, I'll show you 9 real-world examples of types of questions where vector search fails, and I'll demonstrate the retrieval strategies that actually work in these examples. As I said, vector search isn't bad, it's just one tool in the toolbox. There's a lot more to RAG, so let's get into it. Building AI agents in n8n is incredibly easy. It's a simple canvas, you add an AI agent node, you connect up a model, give it a system prompt, a couple of tools, and away you go. And that's great for a quick proof of concept. But in reality, building accurate and reliable AI agents in any platform is hard. And the reason for this is their natural language interface. You can literally ask an agent any possible question in any number of different ways, and it needs to figure out what you need. And some questions can be answered directly from the model's training data, while other questions require diving into a knowledge base. What was our Q3 revenue, for example, clearly requires diving deep into a financial system. And this is where things can get tricky when you're trying to create an accurate and reliable system, because questions asked of the agent can get quite complex. Some questions require synthesizing information across multiple documents, comparing information from different data sources, interpreting and analyzing data, extracting, summarizing, inferring, evaluating, and the list is endless, it's infinite. And the critical thing is, each type of question might require a completely different approach to retrieve the right information to generate an accurate answer. And on the one hand, this is what makes AI agents so powerful. But on the other, this is why creating accurate and reliable agents can be quite difficult. And in essence, this retrieval strategy will ultimately determine whether your project succeeds or fails. And if you strip an AI agent back to its core, there's essentially a simple decision loop that's at play. So when a user's question comes in, it hits an AI agent, powered by an LLM, in the context of a conversation, so there's memory, and it needs to reason and decide, does it have all of the information it needs in context to answer the question? Or do I need to do something to retrieve the information or carry out an action so that I can then answer the question? And it's a loop, so this can happen multiple times. Now, of course, this is a little bit simplified, but you get the idea. And when we think about retrieval, retrieval within the context of an AI agent is simply a tool call. No different to an API call to create a calendar entry or draft an email, for example. So querying a vector store is just another tool call, but it is important to state that there's more to RAG than just vector search. And don't get me wrong, I would love if vector search was the silver bullet for chatting to your data. But here's the major problem. Vector search operates using a similarity algorithm. When you query a vector store, you are getting the most similar results back. But similarity is not the same as relevance. Relevance is highly subjective depending on the question that was asked. If you queried a vector store, for example, looking for information on error code 221, the vector store would happily send you back information on error 220, 221, and 222 because they're all relatively similar. But clearly the most relevant result you're looking for is this one, error 221. This lack of exactness around vector search is both its major strength, because you can find the right information even though you don't have the right words in the exact query, but then it's also a major weakness if you need exactness, like in this case. And this is why there are an array of retrieval methods that you can leverage for different types of questions. Vector search we've spoken about, but if you need exactness, keyword search, pattern matching is a great approach. SQL queries for structured data searches, graph databases for relationships and concepts, API calls if you need to retrieve information from other software systems, file system scans if you need to grab information from disk. And this is why I would define all of these, including API calls, as RAG. Because if through these methods, the retrieved information is fed into context, and it's used by the model to synthesize the answer, then that is retrieval augmented generation. This entire video was inspired by an article I read from Amit Verma, who's the head of engineering at Neuron 7, where he described retrieval engineering as a distinct discipline that's going to emerge over the coming years. And just as how machine learning ops has matured, so too will practices around hybrid ranking, graph construction, and more. And all of this leads to the 9 common question types where vector search may fail and you need other retrieval strategies to answer those questions. And it's worth calling out 2 sources I used when researching this video. One is IBM's Know Your RAG research, as well as the Comprehensive RAG benchmark. I'll leave links for these in the description below. First up are summary questions, and this is the most common question type that trips up our members when building out systems. In this example, we have a database of meeting transcripts. And the question is, what decisions were made in the leadership meeting? The key thing about this question is to answer it accurately, you need to analyze the full transcript of the specific meeting. That way you can extract out the various decisions that were made. So it has multiple units of information. And if we look at an example knowledge base here, you can have different documents that represent different transcripts. You'll have different chunks because meetings can go on quite long, they may be chunked. And decisions are sprinkled across the transcript. And the other thing is, they're not specifically called out as a decision in a lot of cases. So with the standard vector search, without metadata filtering, for example, you would just search for the word decision, and anytime it was mentioned in any of the transcripts, it will be pulled back. So at the very least, you would need to use metadata filtering to narrow in on the specific meeting that the user is talking about. But even then, searching for decisions across that meeting's transcript isn't really going to yield a complete answer. Now, there is a case where it will, whereas maybe at the end of the meeting, if someone was taking notes, they could summarize all of the decisions. And in that case, vector search will return the right result. And this is the grayness of these questions. Sometimes vector search will actually output the right answer depending on the content that's in the vector store, or depending on the iterative retrieval that an agent will undertake to actually research the topic. So we have a number of possible retrieval strategies here. Agentic RAG, as I mentioned, which is iterative retrieval, so the agent can search across the vector store multiple times. But again, it doesn't really know what to search for because it doesn't know what decision it's looking for if it's not called out as a decision. But it can apply metadata filtering to at least narrow the scope. Query expansion for a more traditional RAG system that's not agent-based. But again, you have the same problem here because you don't know what you're looking for. Context expansion is a technique I went into in a previous video. And that allows you to look at the structure of a document and load up the parent section, for example. But this isn't really a document that has a formal structure. But in reality, to get the most comprehensive answer to this question, you need to load the full transcript. And if the transcript is too large, you need a way of batch summarizing the transcript to extract out decisions. And this idea of loading a full document is covered in that context expansion video that you see here. And something else to call out here is, if someone is looking for decisions that were made at a leadership meeting, they should have the right level of access to actually retrieve that information. I have a full video on Zero Trust RAG where I go deep into how you secure AI agents to make sure people have the right access privileges when requesting the information. And that's our first example of a summary question where in reality, you need to process the entire document or the entire transcript to output a comprehensive answer. If you're enjoying the video, make sure to give it a like below and subscribe to our channel for more deep AI and n8n content. It really helps us out. Another example is, let's say we have a knowledge base of documentation for a cloud storage service, and the question might be, what are the main features of the service? The answer could be embedded in features scattered across the documentation. So again, multiple units of information spread out and not specifically called out as features. You could have version control, encryption, device syncing, organization. And if you carry out a vector search, you might pull some of these, but it's unlikely that you're going to pull everything. And that can yield a partially correct answer, not necessarily a hallucination, but just not comprehensive. And vector search can work here if, for example, there's a page in the documentation that lists the features. And that's similar to the example of decisions made at the leadership meeting. If someone goes to the effort of summarizing the decisions, then it's just raw retrieval to fetch the list. And it's the same here. So the heart of the issue here is with vector search, you're talking about raw retrieval of information that's there in a knowledge base. Whereas these types of questions require document processing. So if someone has already listed the features of cloud storage, that processing has already taken place and it's there in the vector store to be retrieved. But if it hasn't, you're going to need to do the same thing again. You're going to need to load the full documentation or iteratively process the documentation to retrieve out features. And this leads us to our third example of a summary question, which is, let's say, a database of internal reports, and someone is asking for a comprehensive summary of a specific report. And to fetch this, you need to synthesize information from every single section of that document. And if you miss any section, it's potentially misleading or incomplete. So it's the same problem again. Vector search will retrieve a limited number of chunks of the document. Agentic retrieval will fetch more chunks, but you are only essentially retrieving segments or pieces of the document. And the document might have an executive summary at the front. So that might be the first chunk that's pulled back. And that's how vector search can produce an answer, but just not a comprehensive answer. Approaches to create a comprehensive summary of a report include loading the full document into context, or instead actually have a document processing sub-agent that you delegate the task to load the full document into context, and that way you don't pollute the full context window of your main agent to answer the question. But if you are dealing with documents that are just too big for an LLM's context window, you need to look at techniques like MapReduce summarization or hierarchical summarization. These are top-down and bottom-up approaches to summarizing large documents. If you'd like me to do a dedicated video on this, then just drop me a note in the comments below. We have other videos on our channel where we go through some of these retrieval strategies. In our RAG Design Patterns Masterclass, I go deep into that idea of sub-agents and delegating tasks to a sub-agent, while my CAG versus RAG video goes into this idea of cache-augmented generation, where you load full documents into context, and you're using prompt caching as a result. We have n8n workflows for the vast majority of retrieval strategies that you see in today's video. If you'd like to get access to those, then check out the link in the description to our community, the AI Automators, where you can join hundreds of fellow builders, all creating production-grade RAG agents. So summary questions are notoriously difficult for vector search to actually answer comprehensively, but even simple questions can trip up vector search. So with the example of a company knowledge base, for a question like, when was our company founded, vector search should perform pretty well here. This answer has one unit of information. It cannot be partially correct. It has to be fully correct. And here within example documents, vector search finds within an about company page that the company was founded in 1972. So here the answer appears verbatim in the documents. The query embedding, when was our company founded, largely matches the embedding of the chunk, which includes founded in 1972, so that should perform pretty well. But if you have queries that include rare terms that aren't actually in the training data of the embedding model, you can run into problems. So for this example query, who created the Blue Sheet system? Blue Sheet is a company term. It's a system that the company created and they just dreamt up a name. And the Blue Sheet project might be contained within the knowledge base. But the problem here is vector embeddings are going to struggle on this domain-specific term because it was totally absent or is underrepresented in the embedding model's training data. And this is where approaches like lexical search and hybrid search make a lot of sense, because you can get an exact match on a term like Blue Sheet, which has very little meaning in a semantic sense. For those types of terms, you could also have a company glossary and have a more structured data lookup, for example. Another simple question example is this type of query, explain, and then you just have a random code that's specific to that company. So explain 15 CFR 744.21. So this could be a company regulation or a policy or something like that. And it'll be contained in those documents. It has one unit of information. It cannot be partially correct, but the embedding model has very little chance of representing this identifier as it was totally absent from its training data. It means nothing really. So here you would need to use the likes of pattern matching to actually find this code, because even hybrid search can actually fail with this. And the reason being, hybrid search tokenizes the actual information. So this code, 15 space CFR space 744, these spaces will result in this code being split. So there is no exact match possible using lexical search because this is now 4 tokens instead of 1. So hybrid search or lexical search can fail here. And that's why you might need pattern matching, which is wildcards or regex, or again, that idea of a structured glossary or structured data lookup. I've gone deep in these topics on this channel. I have a hybrid search video where I show you how to set up hybrid search on Supabase and Pinecone. And I also have a lexical and pattern matching search video called High Precision RAG. So as you can see, even simple questions can trip up vector search. But not all simple questions are simple, they can have conditions. Here we have what looks like a simple question. Who is the CEO of our company? So we should be getting an answer with 1 unit of information. It can't be partially correct, but there's a catch, which is it's recency dependent. This company might have had 10 CEOs over the last 20 or 30 years. Standard vector search is going to search for the word CEO or Chief Executive Officer, and it'll pull out lots of different names from lots of different documents over the last 20 years. So how does it know who is the current CEO? Because that's the implication here. Who is the CEO of our company? The person's most likely looking for the current CEO. Now that could be clarified by the agent, but I think that's the implication here. So a possible issue would be that for whatever reason, the current CEO, Sarah Patel, might not actually be returned at all by vector search. Maybe the vector search will return previous CEOs from older documents. Because generally speaking, vector search doesn't favor newer documents over older ones. It's all about similarity. But a good approach would be within the metadata of the chunks to at least have, let's say, the document title. So if 2025 merger was in the metadata that was fed to the agent and Sarah Patel was returned, then the LLM will more likely describe Sarah as the current CEO, James was the previous, Michael in 2015. And that's where metadata can be used to influence the AI when generating the response, but it could also be used for filtering. That's where you could tag and filter documents, maybe based off publication date, so you could check all documents in 2025, and if nothing was returned, then try 2024. Or you could filter documents by type, so maybe only look at employee records or org charts. Hybrid search might work here because CEO is an abbreviation, not full natural language. Although I think CEO is pretty well represented in the training data of these embedding models. A structured data lookup could work of an org chart that could be in a knowledge graph or in a database table. And re-ranking is an approach here as well. There are new re-ranking models that are actually promptable. So the AI agent could prompt a re-ranker to say, re-rank these chunks based off recency. Now you just need to make sure that the actual date of the document is dropped in there as well. If you'd like me to do a video on that type of re-ranker, again, let me know in the comments below. So you can see that even simple questions with conditions can actually cause problems for vector search. And here's another one. What was our revenue in Q2 2024? It is a simple question. However, it's tabular by nature. And that's where vector search falls down. So there could be reports, PDF reports in a knowledge base that talk about the different financial returns of the different quarters for the company, and they might have different revenue figures returned. But again, it's a little bit of a gamble on what actually will be returned by the vector store. And this ties into the need to build accurate and reliable agents, because an AI agent might actually get this right. It might actually pull the correct report based off the data queried. But then it might not. It might pull a different report. So it's that lack of reliability that then ties into the trust that people have with the system and whether they can actually take the information at face value. So here, answer appears embedded in tables and documents. So definitely actually Markdown OCR makes a lot of sense here. If we are only relying on PDF financial reports, at least get them into a format that is LLM friendly. So the likes of Mistral or Docklane will work well here. But yeah, I think structured data makes a lot of sense. A direct lookup of a database table that actually contains these results would be a lot more reliable. Again, the re-ranking approach could work here. Metadata filtering could work. Or even an API call to a financial system that actually contains this information. Again, we have lots of videos on these strategies on our channel. Alan has gone deep on database agents and spreadsheet agents, so there's a few videos there. We have a metadata filtering video, how to extract markdown tables using the likes of Docklane, LlamaParse, and Mistral. And I also have a re-ranking video which explains what actually it does. Another type of question that can trip up vector search are aggregation questions. So here, for example, if someone asks how many customer support tickets were closed last month, the answer requires computing or counting across lots of different documents. So there is a quantitative output, and it's not necessarily embedded in the text of the documents. So for example, each support ticket might be embedded in a vector store so that it can be searched across. But if you do need to know the number of tickets closed in a specific month, this naturally aligns to SQL queries. So structured data is the best approach here by far. An API call or an MCP call could also work if it's a support ticket software that has an API endpoint that actually answers this question. There's a category of questions that I would describe as global questions that essentially span the entire knowledge base. So for example, what are the recurring operational challenges mentioned across all team retrospectives? So here we need to identify patterns and themes across massive document collections. So there's no single document that contains the answer. Within our example documents, we just have all of our various team retros, where various team issues are talked about. Vector search would essentially return a random subset of retrospectives. So it would be able to provide a partial answer that reflects some of the retrospectives, but it can't really speak to the recurring operational challenges because there's just too much documentation to actually work through. So possible retrieval strategies here, GraphRag is probably the best approach, because GraphRag extracts out these global concepts as entities and it can interlink everything and create community summaries. So the likes of deployment issues or communication gaps, for example, might be interlinked multiple times. If you didn't want to go down a knowledge graph approach, you could use the MapReduce summarization method, where you would process documents in batches, extract themes, and then aggregate everything. But that would be a long-running job to actually undertake, whereas with GraphRag, that's all pre-computed up front. I have a GraphRag video on our channel where I talk through setting up LightRag, which extracts out entities and relationships. There's an entity resolution process, LLM summarization and merges, and you can query LightRag to inject the most relevant entities and relationships into context to generate an answer. With global questions, we're talking about aggregating knowledge across lots of different documents in a corpus. With multi-hop questions, on the other hand, we're talking about chaining information across documents. So in this example question, what projects will be affected if Sarah goes on maternity leave? We need to chain information to generate the answer. So we need to figure out Sarah's current role, what projects she's on, what's the status and the various dependencies in that project. So in our example knowledge base, we could have an employee directory, maybe we have projects and team structures. To come up with this answer, we need to be able to traverse through this chain to figure out that Sarah is on the API team, which is a key part of Project Phoenix, which has a certain project status and is to go live at a certain date. So if she went on maternity leave, there would be a major impact. And simple vector search can return these isolated chunks, but it isn't able to return the connections between these entities. And in fairness, agentic RAG can actually get there. It can perform multi-step reasoning. It could look for Sarah's projects, try to figure out the timelines, try to figure out the dependencies to come up with the answer, but it lacks the reliability that the likes of a knowledge graph would have where the data is actually modeled correctly. That way you're able to traverse the graph to come up with the right answer. So this is one of those cases where smart reasoning models using vector search can actually get there, but there may be a trust issue because you don't know, can you actually trust the answer that you're getting? Whereas with the knowledge graph, it's a lot easier to actually stand over the data. A lot of our members need images to be returned inline in the responses of the AI agent. So with this example question, how do I replace the toner cartridge in the third floor printer? Show me the diagram. The answer requires retrieving and returning visual information. And in the example documents here, there might be equipment photos, as well as an inventory of the office equipment and printer manuals, for example. So this is multi-stage retrieval, and it is actually suited to vector search if the images are embedded in the chunks or they're in the metadata so that they can be injected into the chat. So that's where multi-modal RAG kicks in, where you extract out images from source documents and make them accessible within the chat widget. Metadata filtering would also be important here because you might need to filter by the equipment model. That way you're providing the right image. And agentic RAG would also be important for that iterative multi-stage retrieval and maybe even generating signed image URLs. Alan has a multi-modal RAG video on our channel, which is definitely worth a watch. And I also have a video on how to create a Slack agent, because internal staff in a company might be using an instant messaging platform like Slack when engaging with a system like this. Some of the questions that we come across require heavy post-processing to actually come up with the answer. For example, is our customer churn rate trending up or down over the past 6 months? If this information has not been calculated before, the answer would require significant reasoning and analysis to actually figure out. And for this then, you need to load lots of raw data to calculate the trends and compare values. So ideally, you might have monthly reports and you'd be able to pull everything together, but even vector search might struggle to find those. Whereas in reality, you'd likely need some sort of SQL tool where you can pull structured data and then have a calculator tool so that the LLM could generate accurate calculations. So agentic RAG with reasoning is important here. But for a question like this, if you really want to trust the answer you're getting back, you're better off to have pre-computed the actual answer. So that way the agent is simply just retrieving the answer. It doesn't need to calculate anything. Or again, it might be an API call that you can make to a CRM or to a financial system to get the pre-computed answer back. And finally, there's a category of questions where the actual starting premise is false, and it's important that the LLM doesn't go off track and stays honest to the data. So for example, which VP led the Berlin office before it closed? In this case, the question contains a false assumption. The company never had a Berlin office. So the AI agent needs to recognize and correct the premise rather than hallucinating the answer to fit into the user's question. So example documents here, we might have office locations and Berlin is not mentioned. We might have a leadership history section where the VPs are mentioned, and there may have been expansion plans to Berlin, but there was no timeline set. So it all comes back to the chunks that are returned from the vector store. It's important that the agent stays true to the information that is in these chunks. Because if the retrieved documents mentioned Berlin and VP along with expansion plans, it could quite easily hallucinate the connection Sarah Chen led operations before the Berlin office closed. So strategies here, carrying out an exhaustive search is important. Context expansion could help here as well, that video I mentioned earlier. Having agentic RAG with verification could work here because I went through the verify answer pattern in our RAG design patterns video, and this would allow a verification step to check the answer versus the retrieved context to make sure it's staying true to what it actually learned. But it all comes back to evals and ground truth testing. You need to keep your specialized agents on track. They need to stay true to the data and not dive into their training data or infer connections from disconnected information. I have a full video on evaluating AI systems using the open source library DeepEval, so that one is definitely worth a watch. And if you'd like to learn more about RAG design patterns, including this verify answer pattern that I just described, then click on this video here to learn all about it. Thanks for watching, and I'll see you in the next one.